For installation operators, calculating CBAM emissions. Understanding how CBAM emissions calculations work. This chapter will go through the steps that installation operators need to follow to track the relevant data points, calculate their CBAM emissions, fill in the emissions data communication template that is to be sent to their client's reporting declarants. During the transition period, CBAM applies to 6 sectors, which are cement, electricity, fertilizers, iron and steel, aluminum, and hydrogen. Once the installation operator has a specific good in mind, they can start calculating their CBAM emissions and filling in the emissions data communication template that is to be sent to the reporting declarants. Here are the steps to follow for an installation operator when calculating CBAM goods emissions. Phase 1. Mapping goods to their relevant CN codes and aggregated goods category. Phase 2. Identifying system boundaries. Phase 3. Selecting the simple or the complex goods emissions calculation method. Phase 4. Identifying direct and indirect emission. Phase 5. Monitoring and quantifying direct and indirect emissions. Phase 6. Calculating the specific total embedded emissions. Phase 7. Identifying the qualifying parameters. Phase 8. Calculating the total emissions of the installation operator. Phase 9. Sharing data to their reporting declarants. Note: this section provides theory on how to calculate CBAM emissions. The application of this theory will later be covered within this course. See the For Installation Operators, Calculating CBAM Emissions section within Chapter 5. Reviewing a scenario of this course for application examples on calculating CBAM emissions. Phase 1. Mapping goods to their relevant CN codes and aggregated goods category. To identify what types of emissions will be included in a CBAM calculation, the installation operator first needs to map their goods according to their relevant CN codes, their relevant aggregated goods category. Step 1. Identifying relevant CN codes. Installation operators should map CBAM goods to their CN codes. To do so, the list of CBAM goods by industry sector and CN codes can be found in Annex 2 of the European Commission's Implementation Regulation. Please also check this: how to define a product CN code based on the CPC code and vice versa article from the EcoVadis Help Center to view a mapping of the Central Product Classification (CPC) and CN codes. Definition: the Combined Nomenclature (CN) classification system defines the essential characteristics of goods and is used to identify those sector goods that are subject to the CBAM regulation. It is presented in the form of an organized catalog that codifies goods which are the subject of trade and takes account of the specific characteristics of the goods in question, particularly the type of product, what is it made of, its function, and how it is presented or packaged. Once the CN codes have been identified, installation operators can use the CN code of a product to identify which greenhouse gases need to be monitored, as explained in Annex I of Directive 2003/87/EC. Note: the reporting of CN code is a requirement of CBAM regulation. The calculation of a declarant's CBAM cost should only be done for one good at a time and needs to be categorized by its CN code. Step 2. Identifying relevant aggregated goods categories. Once the relevant CN codes have been identified, the installation operator can map their goods according to their relevant aggregated goods category. To do so, Installation operators can use CN codes to identify which aggregated goods category their goods belong to. Definition: aggregated goods categories refer to goods that are grouped based on their similar characteristics. These categories are created to simplify the administration and implementation of CBAM. Instead of assessing and monitoring goods individually, goods within the same aggregated goods category are treated and evaluated collectively. The emissions of goods falling under the same aggregated goods category shall be calculated separately if different production routes are used in the same installation for producing goods, and where those production routes are assigned separate production processes. These goods shall be calculated separately for each production route. Here is an example of how fertilizer products are mapped out according to their CN codes, aggregate goods categories, and greenhouse gas. CN code. Aggregated goods category. Greenhouse gas. 28080000. Nitric acid. Sulfuronic acids. Nitric acid. Carbon dioxide and nitrous oxide. 310210. Urea. Whether or not in aqueous solution. Urea. Carbon dioxide. 2814. Ammonia, anhydrous or in aqueous solution. Ammonia. Carbon dioxide. 2834-2100. Nitrates of potassium. 3102. Mineral or chemical fertilizers. Nitrogenous except 3102. Urea. Mixed fertilizers. Carbon dioxide and nitrous oxide. The above table depicts how each fertilizer product is sorted by CN code, aggregate goods category, and greenhouse gas. Phase 2. Identifying system boundaries. Once the installation operator has mapped their goods against the correct CN codes and aggregated goods categories, the installation operator needs to define the system boundaries of their production processes and production routes. This means the installation operators need to identify the goods that are subject to the CBAM regulation. Definition: system boundaries of CBAM. System boundaries of CBAM calculation help to define all the relevant production processes and production routes for monitoring and reporting embedded emissions. These system boundaries prevent double counting when using data from different installation operators and guarantee that all the calculations are comparable. Production route. Production route stands for a specific technology used in a production process. The system boundaries encompass all processes directly or indirectly linked to the production process. The system boundaries depend on the aggregated goods category. For example, the production of the aggregated good category ammonia from the synthesis of nitrogen and hydrogen is considered as a production process. The specific technology involved is called the Haber-Bosch with steam reforming production route. There are different ways of accounting for carbon depending on what the installation operator's focus is. For example, CBAM and product carbon footprint, PCF, are both accounting methods. However, they should not be used interchangeably, as they share different system boundaries. How different are system boundaries for CBAM and PCF calculations? Differentiating system boundaries for CBAM and PCF calculations. CBAM is based on but not fully aligned with the principles and requirements for a product carbon footprint, PCF. Definition: a product carbon footprint, PCF, is usually understood as an amount of greenhouse gas emissions, expressed as kg or TSO2e, per declared unit, for example, a ton of good. It is based on a life cycle perspective covering all significant emissions from upstream and downstream processes, called life cycle stages, from mining and production to transport, use and end of life. There are two main differences between PCF and CBAM. 1. CBM has a narrower scope than PCF. The system boundaries of emissions covered by the EU ETS, and therefore the CBM, are narrower than those in a PCF. PCF adopts a life cycle perspective, focusing on upstream and downstream emissions, while CBM primarily focuses on upstream emissions. The EU ETS, and therefore CBM, covers a narrower scope than PCF. CBM is designed to work hand-in-hand with the ETS mechanism, which primarily focuses on carbon pricing of operations and upstream emissions. This means CBM is intended to cover the same emissions as would be covered by the EU ETS if the production were situated in the EU. Here is the life cycle of a product. What are the differences of system boundaries between CBM and PCF? This means the following elements are out of CBM scope. Downstream emissions, emissions from the use and end of life of the products. Emissions from transport of materials between sites and from processes further upstream. 2. CBM collects non-greenhouse gas emissions data points that PCF doesn't collect. CBM requirements cover non-greenhouse gas emissions data points that are not collected via the PCF process, since PCF focuses on greenhouse gas emissions only. Examples of emissions data points that are not calculated by PCF include volume of goods produced at facility level and precursors volumes such as chromium, manganese, nickel, etc. PCF data can therefore not be used to report on CBM due to scope differences, as companies would indeed need to collect additional data points. Phase 3. Selecting the simple or the complex goods emissions calculation method. Once the installation operators have identified which type of greenhouse gas to monitor, they should check whether this emission is considered as simple or complex goods. CBM distinguishes between simple goods and complex goods in terms of emissions calculation. Simple goods are those produced using input materials and fuels with zero embedded emissions. Complex goods involve the use of input materials with associated embedded emissions. These are called precursor materials. It is then necessary to include the embedded emissions of relevant precursor materials themselves in the scope of CBM, if used in the production process. If the product that installation operators are monitoring is a complex good, this means that embedded emissions of relevant precursors should be included in the calculation. To calculate them, CBM allows two methods. Actual emissions are based on specific measurements and data from the production processes. Default emissions can be used in cases where actual emissions cannot be adequately determined or for indirect emissions. Note: from August 1, 2024, the use of default values to determine the emissions embedded in imported goods will only be possible to a limited extent. Default values may only be used if the percentage of the emissions determined using the default values does not account for more than 20% of the total emissions of a product. Phase 4. Identifying direct and indirect emissions. Once installation operators have identified their simple and complex goods, they should differentiate their direct emissions from their indirect emissions. Understanding direct and indirect emissions and precursors. The reporting declarant will need to surrender CBM certificates, meaning they will need to pay penalties for the following emissions. For their direct emissions, their own emissions and their precursors, direct embedded emissions. For their indirect emissions emitted due to electricity consumption and their precursors, indirect embedded emissions. For example, the embedded emissions from the precursors, such as nitric acid, used for the production of fertilizers, is also included in the final carbon cost. What are precursors? Definition. Relevant precursor materials refer to those raw materials used in the production of complex CBAM goods that are CBAM goods themselves. In other words, precursor materials are the raw materials produced and used for the production of the CBAM goods. What are examples of relevant precursors? In the cement sector, cement clinker is a precursor material. It is the main constituent of a type of cement called Portland cement. In the fertilizer sector, mixed fertilizers are defined as complex goods as they are produced from precursors such as urea and ammonia, which are precursor materials. They are the raw materials used for producing fertilizer. Precursor emissions are the emissions emitted when producing urea and ammonia. Precursors could be produced within the installation of the operators or purchased from other installations. For precursors produced within your installation operators only need to take the precursor's embedded emissions into account when calculating the embedded emissions of the goods that use the precursor in the production process. For precursors purchased from other installations, installation operators would need to request data from the relevant producers. What is expected of installation operators? As installation operators have direct access to information on the emissions of their installations, they are responsible for collecting, tracking, monitoring and providing the necessary data related to the direct and indirect emissions associated with the imported goods they have produced and are exporting to the EU. This data includes information on the production processes, specific embedded emissions, and other relevant factors. What is the relationship between these different types of emissions, and how both installation operators and reporting declarants need to manage these? View the animation to better understand these relationships. How should installation operators share this information with their reporting declarants? Sharing this data with reporting declarants. To share the necessary embedded emissions data with reporting declarants, installation operators should fill in the emissions data communication template, which they can then share with their reporting declarants. The purpose of this template, provided by the EU, is to facilitate the communication between installation operators located outside of the EU and their reporting declarants. It will also support installation operators in calculating the direct and indirect emissions of their goods. The emissions data communication template can be found in the European Commission's Carbon Border Adjustment Mechanism webpage, under the CBAM Communication Template for Installations section. On the EcoVadis platform, when users add new CBAM data within the Carbon Product Data tab, the information to provide in this template is listed in the Annex 4 of the Implementing Regulation document. See Chapter 6. For installation operators, disclosing product-level data with EcoVadis tools. For additional information on how installation operators can report CBAM data using the EcoVadis platform, let's look into an example of a fully filled and emissions data communication template. To view what a fully filled and emissions data communication template could look like, the European Commission provides downloadable examples for each sector: cement, aluminum, fertilizers, hydrogen, steel, electricity. To access these examples, go to the European Union's website and under CBAM Communication Template for Installations, download and select the emissions data communication template you require. For this specific scenario, we will focus on steel and iron, and we'll be using the emissions data communication template called CBAM CV2.1_example steel 1 blast furnace _final. Watch this short video to view an example of a fully filled and emissions data communication template for the steel and iron sector. Press play to find out more.
The communication template provided by the European Union will help installation operators calculate their goods' direct and indirect emissions. For a better understanding on the use of the communication template, the EU has provided examples of the field template. The field example of the emissions data communication template could be downloaded from the session CBAM communication template examples. Click Download to proceed. Once downloaded, examples of the field communication template for each sector, including cement, aluminium, fertilizers, hydrogen, and steel, will be available in the downloaded folder for your reference. For the use of the emissions data communication template examples in this video, we will be using one of the examples from the iron and steel sector, which is called 2 CBAM SEE version 2.1 example steel 1 blast furnace final. Please also check the EU website regularly for any updates in the examples provided. Firstly, the Guidelines and Condition tab describes the color codes of the fields. Yellow fields indicate mandatory input from the installation operators. Light yellow fields indicate that an input is optional. Green fields show automatically calculated results. Next, this sheet named Code List provides explanation of the various kinds of codes used in this CBAM communication template. For example, for Session 1, you could find codes for countries and currencies. For Session 2, you could find the common nomenclature codes for CBAM goods. The list shows the CN codes and the corresponding names of all CBAM goods and the aggregated goods category to which CN code pertains. Next, this sheet named Sheet 8 Installation Data requires the input of general information, production processes, and purchase precursors of the installation. For example, under the About the Installation section, it requires the input of the name of the installation, postcode, and country, etc. The aggregated goods categories and relevant production processes sections requires the input of all aggregated goods category, including any relevant precursors types produced within the installations. The purchase precursor sections requires the input of all precursors that are produced outside the installation and the corresponding production routes. Next, in Sheet B, Installations Emission as Source Stream and Emission Source Level. This sheet helps to calculate the energy content and the greenhouse gas emissions for each source stream and emission source. The required data have been entered as an example, including the method of calculation. Mass balance method is used for this particular example. Source stream name. For example, coke fines, iron ores, etc. Activity data. For example, amount of coke fines or iron ores used in the production process in tons. A unit of activity data, such as tons. Carbon content of the fuel and materials. Please note that these fields are all highlighted in yellow, meaning that these are all the mandatory fields required to be entered by the installation operators. Next, in the sheet C, emission and energy. These sheets help gather information on the fuel usage, greenhouse gas emissions balance, and information on data quality. Firstly, the total direct emissions is displayed in cell L25. The cell is highlighted in green. It means that the cell is automatically calculated once all required fields in the previous sheet on installation emissions are filled correctly. Secondly, the total indirect emission data is displayed in cell M26. The installation operator needs to calculate the total indirect emissions before filling in these fields. Next, in the sheet summary processes. The sheet provides a summary of the installation, process, and production routes. Cells highlighted in greens are filled automatically based on the information inputted in the previous tabs. And the table, greenhouse gas emissions balance of the installation and all production processes, calculates automatically the impact of heat and waste gas emissions on the total direct and indirect emissions. As a result, it is calculated automatically that the steel and iron imported has the following reported and verified emissions. Total direct emissions of a production process for steel and iron products, including the precursors materials, equals to 7,387,085 tons of CO2 per year. Total indirect emissions, including the precursors materials, equals to 976,919 tons of CO2 per year. Also, the specific direct and indirect embedded emissions are also calculated automatically, as displayed in this section. For more details on this specific example, please refer to Example 1, Integrated Steel Works and Conversion to Iron or Steel Products, available from the guidance document on CBAM implementation for installation operators outside the EU. Thank you.